Okay, so let's take off where we left off. We left off talking about this critical value of t, or the t statistics, the t statistic that is used to explain paired samples t-test. Okay, so going back to that, let's talk about what that actually means. And I'm going to do it using an example. This is an example of the actual chart that is available to determine critical values of t. Let me point out a few things for you. You have level of confidence, okay? Generally what we focus on is the 0.95 or 0.95, which in this article, we do know that they are using alpha level of 0.05. So we can expect that it's based off of 0.95 confidence interval because the level of significance is a 0.05. They're also telling us that it's two-tailed. Well, what does two-tailed mean? We're going to talk about that. But know that this is what they're using, okay? Alpha, or level of significance, is 95% with an alpha of 0.05, which is the same thing, and it's two-tailed. Now let's go back to look at that, okay? This chart helps you to determine this point, or the 7.05. Now, how does it do that? Well, okay, let's take a look. T is, again, the statistical term. So if we go back, T equals the mean of differences over the standard error of mean. That's this T, okay? That T is generally represented as something like this, just like you saw in the article, and in this case it equals 7.05. This is called the degrees actually of freedom. Now, what does that mean? Degrees of freedom tell you how much room we have to vary. Okay, so let's go back. Now let's take a look at this. This says, find the critical value, okay, for a 95% confidence interval when the sample size is 5. In this case, we're going to use, again, confidence, level of confidence is 0.095. We're going to use, well, I guess in the case it doesn't matter, but know that there's a one tail or two tail, okay? And we have degrees of freedom and then these values that are already calculated for you. So what you're going to do is take the sample size and you're going to go n minus 1, because n is the sample size, minus 1, and this gives you 4. So the degrees of freedom, or the allowed room to vary, is 4 degrees. So here's your 4. And you're using 0.95 confidence interval. You're just essentially going to go all the way over and come all the way down, and that is your critical value of T, 2.776. Okay, stick with me. It will make sense. Now, remind you that this is for a paired t-test. Okay, so the degrees of freedom are going to represent something a little different. So in this case, right, we used it for the sample size, which is very much true. But because they told us that this is a paired t-test, okay, it also says down here, paired t-test, okay, the degrees of freedom, which is this 52, is actually, well, I should say n is the number of pairs of scores. So n minus 1 gave us 52, and using the same chart, again, this is an example, but you would just do the exact same thing. We know it's based off of a alpha level of 0.05, which is a level of confidence of 95. We know that it's two-tailed, so we're going to go over, and that's how we figure out our critical value, okay? For this point, that's all we need to know now. But let's talk about now what is one-tail, two-tail. So there are options of how you would like to explain or further make valid assumptions for your statistics, okay? Okay, so let's just continue on. This is where we are. We're talking about this t-statistic, okay? And here's an example again of that t-statistics. They have t in parentheses 52 equals 7.05. Well, let's figure out what that means. I'm going to use this chart to help explain that. And I've already kind of wrote on it, sorry. So you have TC, this is T, and then the critical value for a 95% confidence interval. Okay, so this is the example. Find the critical value for a 95% confidence interval or confidence when the sample size is 5. So essentially, this is what they did. They were told that the confidence, that the level of significance or confidence interval was 95%. So that's where they got this from. All right. Now, for this case, we're talking about the sample size. So the sample size was 5, and because this value is based off degree, or this statistic is based off degrees of freedom, which I will explain, you have to take n minus 1, okay? So n minus 1 equals 4. So you're allowed 4. You're allowed to vary 4 degrees of freedom. Now, what is degrees of freedom? Degrees of freedom is how much room you're allowed to vary. Again, this is all to determine how true are your inferential statistics, okay? So we need to know how much room do we have to vary in our statistic to determine if it's true or not, okay? Based on this, we're allowed to move 4 because they took the sample size of 5, subtracted 1 per the equation, and got 4. Then they went to 4. They know that it was 95% confidence interval, and they went down. And they went over. And that's how they came up with that 2.776. This is an actual number already determined. You're just following the chart to get to that correct number. So T4 in parentheses 4 equals 2.776 is the actual critical value of T. Now let's talk about this further. Again, we're using paired t-tests. So the t-statistic is based off the means of differences divided by the standard error of differences. But because this is a paired t-test, degrees of freedom actually is still n minus 1, but this is referred to the number of pairs. Of scores, because remember, paired t-test looks at matched scores, okay? Now, let's talk about the one tail, two tail, because here you see one tail, and then here you see two tail. Now, back in the study, they told us that we're going to use a alpha level of 0.05 and that it's two-tailed. Now, let's go back to our chart of normal distribution, okay? When we talk about normal distribution, we have critical regions, essentially. If you see two splits like this, this means that it is two-tailed. If it only has one, then we know it's one-tailed. This is decided before the experiment happens. Okay, this is where we're helping to base our decision on as far as critical values, because we need to know where do the critical values fall into this normal distribution to determine should we reject or accept the null hypothesis. So in a two-tail, in this area, this is critical region, and in this area, again, critical region, we're going to reject HL. Oops, sorry. So if our critical value falls in here or here, reject it. reject the null hypothesis. If it falls in here, though, we don't. Okay, so you do not reject the null hypothesis. So all of this, again, is to determine, do we reject or not reject our null hypothesis? If a calculated T ratio falls within the critical region, the ratio is significant. If the ratio is less than the critical region, then it represents a difference that is not significant or likely due to chance. And this area is not significant. Okay, so it should fall in one of these areas in order for us to determine if we should reject our null hypothesis. Now, they decided to use two-tail to give them more regions. But again, we'll go into that later. That's kind of where I want to explain, stop for now to explain. So this is based off a critical value using degrees of freedom to determine what that critical value is. Whew, that was a lot to talk about. Now let's take a look at that for a minute and go to results. Let's talk about results as we go into this. Okay. So our convenience sample consisted of 72 family caregivers of, Our convenience sample consisted of 72 family caregivers of people with dementia who volunteered to participate in the study. Of the 72 enrolled in the study, 53 completed the pre and post testing in the first module. Similarly, 46 completed the evaluations after the second module, and 45 completed them after the third module. One participant attended but did not complete any of the evaluations. And each module occurred 1 week after the previous module, which contributed to the variability in enrolled participants in the subject. Interesting. Keep that in mind. All right, now let's skip down to the next section where it says caregiver knowledge gain. And in case you're wondering what page I'm on, it's 216. A significant gain occurred in caregiver knowledge after each module. Mean caregiver knowledge of communication and nutrition before training was 73.87 percentage points. Standard deviation, 19.75. When we reassessed caregivers after training using the knowledge test, we found that their knowledge had improved to 92.13 percentage points with a standard deviation of 14.49. A paired samples t-test indicated that their knowledge gain of 18.26 percentage points because they started with what? 73.87, and then they improved to a 92.13. They had a gain of 18.2 percentage points, which was statistically significant based on that T statistic because it fell within that region, and a p-value of less than 0.01. Less than 0.05. So that would mean that it is statistic. And this D, that would mean it is statistically significant. This D equals 0.97 is called Cohen's D, which we did talk about up here. So Cohen's D as well is the effect size. Effect size. Oh, there's something else we need to talk about. All of this was based on the effect size of D equals 0.97. Now let's talk about that in the next video.